Hi, I'm Scott Campbell with Solve 3D.
And I'm Kevin Miller at Solve 3D.
Kevin, in this video, you're going to walk us through how to use a trained model that we've already trained up to identify objects in a scene view, or maybe even call it a panoramic imagery or a spherical imagery.
That's right. So again, just to kind of get started, we got to load our panoramic images that we want to run our classification on. So inside the engine viewer, we're going to click Add Item. I'm going to add my panoramic. It's the exact same stuff that I did in the previous video, in the training video. So go to Pano, go to Training Data, and I'm going to add the CSV file. So this could be the same set of data, and we're going to run it on all 1,000 images, or it could be, a totally new data set that you just collected down the road. But for the workshop, we're just going to use the same data. So we got 1,000, and I got to set my projection again. Again, this is Colorado North in this case. There we go. Okay, so we got our positions of our cameras, and we have our panels, and we can drive down the road. So to run the classification, we simply go to Tools, Scene View Classification. And we're going to focus on a couple things here in this video. So we're going to focus on this Run Classification button, and then I'll talk briefly about importing and exporting data at the end. So we'll start with Run Classification. And again, just like in the aerial image training, we got to specify a classification score or a level of confidence. So in the case for the workshop data, and for most panoramic image objects, I recommend starting with something fairly high, maybe even 0.97, indicating 97% confident. And again, it's only going to return results for objects. In this case, we did traffic lights that are 97% confident that it's a traffic light and higher. This is going to reduce some of your false negatives that appear. So, you might, if you look at this little bullard here, it's kind of the same colored or this barrier, same color as a traffic light, but obviously it's not a traffic light. So that might be, 50% confident or whatever the machine learned from it. So you want to make sure you have this number high enough to remove results like that, but still get all of your traffic lights. We're going to go select the model. And again, we're going to go select the ones from my results. And the PTH file is the one we're looking for. We click Open, and then we can hit Submit to start the training. So again, if this is the first time you've been running any of the ML tools inside of Engine, it may start downloading some of the ML resources first, and you'll see that in the progress bar. Right now, I've already done that, so it's now starting to crunch through all 1,000 photos and find all of the traffic lights. So.
Okay, well, let's fast forward through this scene view classification towards the end and take a look at the results.
Sounds good.
Okay,
Scott.
So yeah, there it is. There are the results.
Done. So it found, if you look here, found over, it looks like 278 traffic lights. So these are something to keep in mind. These aren't the total count of traffic lights. This is the total count of traffic light. It's found in all 1,000 of these photos. So you see it's found 4 or 5 of them here, but if I go to the next image, it found the same 4 or 5 plus some more. So, overall, as I move through the scene and look back at things, you can see it found, that's where the 278 come from, but there really might only be 20 or something in the end.
Yeah, so they're not unique. The 278 is 278 labels, but not necessarily 278 unique traffic lights.
That's right.
Yeah.
So at this point, you're going to want to do a couple things. Maybe you're happy with the results and you can continue, which we'll get to in a second, and we can do some exporting of the positions of these things. Or what I recommend doing, especially if this is your first time labeling some objects, I recommend looking through a few of these, which you can do by driving down the road like I was doing and looking at them, or you can expand the traffic light class here and start clicking on each of these areas that it found and, check, is this actually a traffic light? Yes, good. And maybe click through a few more of these and scroll and just kind of spot check them. I have found that depending on, excuse me, depending on the object that you're doing, you may have, like I mentioned before in the training, you may have some false negatives appearing or even false positives, depending on what you set your classification score. So just make sure you're happy with the results. And again, you can, if you do need to resubmit for training, you can edit these just by, dragging their vertices out and reconfiguring them, or maybe deleting one that's not supposed to be there. You can just right click and delete on it, or delete from the list here on the left.
And of course, the tip that we are making in the other classification tool videos, if you're getting a false positive, in other words, let's say it picked the street sign there as a traffic light. One tip is to create another class, change that street light into that class, call it street signs, and then resubmit for training so that you tell the algorithm that, hey, okay, well, you thought this was a traffic sign, but it's actually a street light. Or sorry, you thought it was a traffic light, but it's actually a street sign.
That's right. So, and again, I do recommend, these are good results. I'm pretty happy with them. So I do recommend at least exporting them as a 3DL file, just so you can save them for later. And to do that, you just click this export labels function, and you're going to see the 3DL here. You can give it a name, and like in this case, I gave it traffic light results and saved it. So that would just save it for later. You can always re-import it using the import button, and you'll be exactly where you are here again. So now we'll talk briefly about how to export the positions of all these detected traffic lights into a CSV file. So to do that, you click the export label positions, and you'll get this rather wordy modal window describing a couple different things. So we actually have two different export methods for exporting CSV positions. They do two different calculations in the back end of how to find those positions of those points. It's an estimation of where those traffic lights are. One we call the point sensitization method, and the second one we call the ray intersection method. So both of these have their pros and cons. I cannot recommend one or the other, and it really depends on your objects and how many were detected and how many overlapping objects were found between different pictures. And so that's the key thing is, as long as you found results and you're not, you don't drive down the road and see a whole bunch of unlabeled traffic lights that are obviously traffic lights, as long as you find some overlapping positions, you should be pretty good with both of any or either or of these methods. So I'm going to go back to this. I'll run both of these methods. I'm not going to change any of these default parameters. We're going to leave them on the default for the for these traffic lights, but for other object sets, or if you have some really complex objects that are very unique, very few objects in your scene, you might want to play with these numbers a bit to be able to export their positions. And again, our user guide goes into a little bit more detail on what each of these advanced parameters do and how they affect the export. So we'll do the point sensitization method. And I'm going to go to my results. I'll just make a new folder in here called point. One thing to keep in mind while this runs here, I'm just going to hit submit. So again, we got a progress bar and you can see the percentage go up. One thing to keep in mind here, if you do have multiple classes defined, you're going to get a CSV file for every class, and the estimate for the objects in each of those CSV files will be exported. So meaning that right now I just have traffic lights, so I should expect one CSV of traffic lights. But if I had traffic lights, road signs, light poles, etc., I might have 3 CSV files that are exported, each with their respective objects inside of them.
So while Engine is off doing its thing here, there's a couple of key points I think is a good time to bring up. Number one is this is actually doing a calculation prior to exporting the CSV, which is what the progress bar is all about. The second is that as it's doing its calculation, it actually is estimating. So this is not a an ultra precise location of each of the objects. It's an estimation, and that's what Engine is producing.
That's right. And I'll load up some of these into Encompass and show you kind of how the estimation works there, and then might get a better idea of what to expect anyways. So it's finished the point one. So we'll do this again. I'll just show you the ray intersection one. Select ray intersection. Slightly similar parameters, but a few less here. I find this ray intersection method is a little faster in some cases, but it sometimes can miss a couple objects depending on, again, overlapping and that kind of stuff. So I recommend trying both and see what you think for the results. So again, we submit. You can see this quite a bit faster. And it's done here. So we'll quickly take a quick look at this. Go to the My Results folder. Under Point, we'll look at the CSV file. So here we go. We got 26 objects that were found, a unique name for each of them. You got the class type and the easting, northern, and elevation or XYZ of each of those positions.
So there's two, before you close that, there's two key points there, I think. Number one, if you remember, the traffic light label total was 278. And our calculation, our estimate calculation, resolved it to 26 actual traffic lights. So we talked about that a little bit earlier. The second key point is this CSV file looks an awful lot like a point of interest CSV file for Encompass.
That's right, yeah. And you can actually import these CSV files directly into Encompass. You don't have to modify them at all to do that. I just want to show you the comparison against the ray intersection method. We'll even open them side by side here. Oh, it won't actually let me. Okay, let's just close that one. Just remember there's 26 traffic lights in that other one. In this one, there's actually only 22. In this case 22, yeah. But again, similar format, you get your easting, northern elevation, which you can import. So you can see, yeah, they're slightly different numbers, but they both use different techniques. And again, it really depends on the objects that you've labeled or that have been found and how many overlapping between different images, how many overlapping objects are the same. So yeah, just briefly, we'll just pop into Encompass here. So I've imported these as, you see here, the same data, that same kind of perspective that we're looking at from Engine. Just minimize Engine here. So I've imported these as two different folders, the blue ones being the point method, point synthesization method, and or I guess there was 25 when I imported it before, and then the 22 for the ray method. So you can see for the most part, the positions are relatively the same in both methods. Both of these, all of these traffic lights have, or mostly all of them have 2 pins. You see this one, I'm not sure what's going on here. One method found this traffic light properly, where maybe this is the same one in the point method. It's not even close. So again, it's an estimation. It tried its best to find that position, but in some cases it may not work. And this could be a number, there's many factors that could be at play here of why this is. It could just be those parameters that were used, those default parameters that were used when we exported the positions. It could be your labels didn't have enough overlap when they were detected, so you might want to go back and label a couple more, do some more training, and then reclassify and re-export. A few different reasons. So, but again, we can jump around and take a look at some of these wherever they might be. Here's a different part of that project. Got a few more weird things going on there, but.
And of course, these are now points of interest inside Encompass. So they behave exactly the same way as any other point of interest. And if you need to refresh on that, just pop over and look at the videos that we have on points of interest in Encompass.
That's right. Yeah, you could delete them or move them and clean them up at this point if you need to.
Okay, well, that's great, Kevin. Thanks very much.
No problem.
There's quite a few key points in this video, so let's start at the top and review them. First, when you're doing your object identification, be sure to try a number of different settings for your classification score. It will depend upon the model you're using and the data that you have, and of course the results that you need. The model will find the number of instances of your object in each image or camera location, not the total number of unique objects. You can edit the results, especially if it's your first time using the model, and resubmit for further training if you need to. In particular, you can create another class of example objects, the second or third class, to give the model more context about your example objects. For example, if, as in this video, you're trying to identify traffic lights, but you're getting some street signs showing up in your results, create another class, call it street sign, relabel the ones that it found thinking that they were traffic lights, relabel them as street signs, add some more street signs in, and resubmit to training. And the algorithm will then take that extra information and create a new model which may give you better results. While the model will not tell you the number of unique objects in your imagery data, we have created two functions that will give you an estimate of the number of unique objects as well as an estimate of their location. One method is called the ray intersection and the other is the point synthesization method. I recommend you try them both to see which works best for you. Now, both of these methods are affected by the number of labels that are created by your model. So if you're not getting the results that you want, I'd recommend you go back to your model, look at your training data, and look to see if you need to increase the number and location of your example object labels. Now, when you got the results, you can view them by importing them into an Encompass project, where they appear as regular points of interest tags.